I'm sorry, I've only just started recording because I couldn't record outside, but we will look at this particular calculation and we'll make sure that we can do it. So, because this is the most important. So for a mass, it's the moles equals the grams over the RFM, RAM or RMM. And for a solution, moles equals concentration times the volume in cubic centimeters over 1000. Okay? So just have a go at that. And what I'd like you to do is to be able to tell me the moles of zinc and the moles of HCl, so you can tell me which is in excess. Everybody have a go. Oh, Wamuini, I've already got the answer. Oh no, he's just eating his paper. He's very hungry. Silver Spring, try to share a calculator if you can get one. If not, even if you don't have a calculator, see if you can just write down how you would do it. Then I can give you the answer and then you can write down the answer afterwards. Okay, that's quite important that you know how to do the calculation. Okay, so here, so for each one of these, the moles equals, for this one, it's the mass over the RFM or RAM in this case, which is going to be 1.96 divided by 65.4. In this one, moles equals concentration times the volume in cubic centimeters over 1000. That's to turn it into cubic decimeters because the concentration is in cubic decimeters. So that is going to be equal to 0.2 times 100 over 1000. Okay, so that's how it's going to go. So I think your answers will be fairly straightforward to come up with. They're not complicated. Yes, show me, Dandora. 0.02 for HCl and 0.03. Well done, Dandora. Well done. Very, very good. You are very sharp. I like that very much. If you want to do this, what you can do is to, Dandora, you can move on and try and calculate the volume of hydrogen which is produced. If you want to do that. Mathari Mixed have got the answer as well. I think. Glory, has anybody got the answer? Have courage, Glory. You are in an excellent, excellent place. I would like to see some answers. Come on, Church Army, start having some courage. You are the Church Army school, high school, so you should be brave and courageous, intellectually courageous. So you should be able to show me an answer. Mathari Mixed have been very good. Silver Spring don't have enough calculators, which is a shame, but don't worry, because in an exam you would have a calculator. So as long as you understand the method, that's okay. Dandora going, well, yes, in Thomas not got any answers out of him yet. It's rubbish. Nor actually from the headmistress. Headmaster, headmistress, very, very slow with their calculators, which is poor. Anyway, there've got to be weakness somewhere. Great leaders don't necessarily have calculators. Okay, so, Wamuini, do you want to show me the answer? Whoops, up a bit, down a bit, across a bit. Hello, Yestin. Very good. Well done, Wamuini. That's excellent. Yes, absolutely. So the answers come out as here. Oops. Here, this one is 0.03. And this one is 0.02 moles. So that means that this one is in excess. So you get 2 marks for writing that. For calculating, showing your calculation here, and then saying, therefore the zinc is in excess. The next bit of the question says something different, asks you to do something different. So we'll go back to the other we'll go and share. Here we are. Okay, so here's the last bit of this question. It says, calculate the total volume of hydrogen gas that was liberated, that means produced, at STP, that means standard temperature and pressure, which is 0 Celsius and 1 atmosphere. And it says that's 22.4 litres or cubic decimeters, they're the same, and that's another 2 marks. So now what I'd like you to do is, knowing that the zinc is in excess, so the zinc will not all be used up, I want you to work out the total volume of hydrogen that will be produced. Have a go at working out the total amount of hydrogen that will be produced. So to do that, what you need to do is to look at the equation. Not all the zinc will react, but all the HCl will. Then you need to look at the ratio of HCl to hydrogen. If I had 1 HCl, 1 mole of HCl, how many moles of hydrogen would I get? And then you say, okay, I haven't got that much. I've got what you've just calculated. So now I can work out how many moles of hydrogen I have, and therefore what volume it will be. Everybody have a go. Everybody have a go at that particular bit of the calculation. And yes, you, Euston, as well. Yes, and you missed. I went out in my garden and got a snowball, and you know, a bit meaningless, but hey, cheered me up.
I didn't miss it at all.
Oh, did you not? Oh.
No, I saw you put it. No, I was watching you going upstairs and putting on your outdoor shoes, and then.
Oh, sorry, mate.
I was fixed avidly to it all.
Transfixed. I know. Yeah, I was too. I've got very wet feet now.
Transfixed. That sounds a bit woke.
Yeah, it does a bit, doesn't it? I'm so woke you can't imagine how woke I ain't.
Yes. Yeah.
How are you, mate?
All right. Thank you. Yes.
Good. Yeah.
Yeah. I'm off to Kenya to next week.
Oh, seriously? Wow, you are lucky. Oh,
meeting up with the headmistress and team.
Oh, that'd be really good. That'd be really good. Dandora, you have got 1 mark, not 2. You have got 1 mark, not 2. You have the answer 448. The answer is not 448. Look at the equation and look at the ratio. If you had 1 HCl, how many hydrogens would you get? So you have to work out the ratio of the hydrochloric acid to the hydrogen first. Take the number of moles of hydrogen. Let me just have a look. No, no, you've gone the wrong way. You've gone the wrong way. Dandora, divide. Oh, yes, I know. One more we need. Come on, let's have an answer. Seriously, you're going out to see the headmistress in Kenya? I am so jealous, especially when the weather here is so pants. It'll be so nice there. Oh, Mathari mixed. Let's have a look. Mathari mixed. Okay. Yeah. Well done. 1 mark out of 2. 1 mark out. You've done the right thing, but you've missed 1 point. I will go through it in a minute, but look at the ratio of HCl to hydrogen. Okay. If I had 1 mole of HCl, how many moles of hydrogen would I get? Look at the equation. Because when you've got the equation, it should make more sense. Right, I will go to the other board now. If I can find my camera. And let me just show you how we do it, because you're going to have a go at another question in just a minute. Okay, so here it is. Let me just, oops. Okay, so here it is. So we have got down, we've worked out the number of moles. We've worked out that the number of moles of zinc was more than the number of moles of HCl. So I'm just going to get rid of that and put it up here. So I know this is excess. So that's not important. And that means there will be some zinc left over. And this is 0.02 moles. At this point, you have to look at the equation. And in the equation, it tells me that this makes this. And the key point is this here. That means 2 moles of HCl will produce 1 mole of H2. So 0.02 will produce not 0.02, but 0.01 moles. That's a really important point, because two students, at least 2 students, worked out that the answer was 448. And it's half that, because it's 0.01 moles times 22.4 will be just 2.24, and therefore 224 cubic centimeters. Okay, so oops, there we are. So that's how we do it. So we say 0.01 times 22.4, and that will give me the answer. Okay, I'm going back to my other camera. Okay, so there we are. Okay, so that's how we do that calculation. We need to use all 3 of the triangles. Moles is grams over RAM or RMM. Moles equals concentration times volume for solution, and moles equals volume over 24,000 or 22,400. So let's have a go at another question. Let's have a go at another proper examination question. Whoops. Okay. So this is another calculation. It's another proper KCSE question. And what we're going to do is I'm going to give you some time to work it out. I'm going to give you about 10 minutes to have a go at this. I'm going to read out in case you can't see it from where you are. So we're starting with, I will help you a little bit on the board. Zinc sulfate is used for putting zinc into the body, because without zinc we get quite a number of ailments. We get quite a lot of dietary problems, which lead to us not having very good immune deficiency and so on. Having immune deficiency and so on. So in this experiment, 3.715 grams of crystals, that zinc sulfate with water attached to it, is heated. And it's heated until it doesn't lose any more mass. Now, at that point, all the water has gone. And afterwards, the anhydrous zinc sulfate, it should say, it said anhydrous zinc here, it should be zinc sulfate, had a mass of 2.08. What you want to do is to work out how many moles there are of anhydrous zinc sulfate, and then how many moles of water, and therefore, like an empirical formula, work out the value of N. Okay, that's the number of moles of water in it. So we're starting with 3.715 grams, and it goes down to 2.08. I'll just show you that on the board, on the other board. I'll just explain it for those people who are not very happy about this. So in this case, we start with zinc sulfate with a certain number of moles of water attached to it. Okay, that's not very clear. I'll just make it a bit heavier. ZnSO4, and we write a full stop. Most of you will know this. That full stop there means these are what we call waters of crystallization. And we start with 3.715 grams of this, okay? And then we turn it in by heating into zinc sulfate, which will be a solid, and the water, which will escape as a gas. Okay, that will escape as a gas. Okay. And this is, it's heated repeatedly. We keep on heating it and reweighing it until we know that we have evaporated all the water. This is 2.08 grams. So that will allow you to work out the water. And then we want the ratio of the moles of water to the moles of zinc sulfate. And that will tell us what the value of N is. Okay, so let's just have a go. Let's just have a go at that. The RAMs, zinc is, oops, sorry. Zinc is 65.4, sulfur is 32, oxygen is 16, and hydrogen is 1. So that's any RAMs you might need. Oh, sorry, Church Army, I missed that. Do you want to show me again? -2.715 -2. Oh, very good. Well done. Was 16.35 divided by 18, 0.09. Okay, so now Wamuini, now you need to work out the ratio of the water to the zinc sulfate. So you get the zinc sulfate, the dried out, the anhydrous. That's that one there, the anhydrous. You need to work out the moles of that and the moles of water and work out what is true about both of them. So first work out the mass of water. 3.17. No, not quite. The 3.175 is the we're on the right track, but the 3.175, I'll just show you something. We don't divide anything by 3.175, okay? That we don't need to do that. I'll just go over to the screen. So the first thing we need to do is to work out the mass of water, okay? So the mass of water would very simply be the mass of the zinc sulfate at the beginning, 3.715 minus 2.08, which will equal, oh, you probably can't see mine. Anyway, it equals 1.635. So this is 1.635 grams. Then I need to work out the moles of this and the moles of that and look at and divide them both by the smallest number. Okay? Divide them both by the smallest number. If you've worked out the RMM of zinc sulfate, it should be 161.4. Okay, I'm going to share my screen. Oh, can I see again, Dandora, please? Uh, 2.27, 1.27. No, oh, hang on. 1.27. You divide by the smallest. It's not by the masses. We've got 3.9 by Church Army School. I'll show you just now. 3.9. Let me just. Is that the ratio? You think it's 1 to 4? 3.9 is close enough. Let me try and show you it. I will do mine now. Okay. So I will do it the way I would do it now. So here we go. Oh. Okay, so I know I've got zinc sulfate is 2.08 and water is 1.635. So if I go, I'm going to write it over here now a little bit more. So if I have zinc, whoops, not a good pen. If I have zinc sulfate and it's 2.08, I divide that by its RMM, which was 161.4. Most of you got that. And that gives me a number something like 0.012 moles. Now I do the same with the water, and I get 1.635. So my water, 1.635 grams. That will be divided by, by 18. I don't want to write on my wall. And that will equal 0.091, I think it is, something like that. So then I look at these two and I divide them both by the smallest number. So I go, okay, this is that's the smaller one. So I divide that by itself, that becomes 1. And this one I divide by the same number over here, the smaller one, 0.012, which looks like it comes out as about 7. And therefore it will be ZnSO4.7H2O. That's the answer. Let's just look at the system again, how we do it. So the first thing we needed to do was to work out the mass of the water, which was the original mass, the 3.715, minus the 2.08, which gave me this number here. Then the moles are this divided by the RMM of zinc sulfate, 4 16s, 132, 163.5, and the water divided by 18. The numbers come out as 0.012 and 0.091. Then to find the ratio, I divide both of these number of moles by the smallest one of them. This is smaller. So this divided by itself is 1. That divided by this number is 7. And so it's 7H2O. That's quite a hard question. It's quite a hard question. Let me just show you what, I'll just remove that, go to my other camera. Okay, this is how the mark scheme was given. Whoops. Okay, hopefully you can see my screen now. So in the mark scheme, this is what they did. Let me just show you this. Okay, this is the question. I mean, it's quite a long question. And the first thing was, it said how many moles of zinc are there in the anhydrous zinc sulfate, then how many moles of water, then the value of N. That was 6 marks. That's a lot of marks. Okay, so here is how they did the answer. Okay, so they gave 2 marks here for working out the moles of zinc. There we are. Then 2 marks for working out the moles of water, and then 2 marks for finding out the 7. Now that's a lot of marks, and it's a big question. Okay, so I'm going to stop sharing, come back to my other camera, change cameras. Okay, that's quite complicated. So we've done 2 quite difficult questions so far. For the first one, which was about starting with zinc and hydrochloric acid and working out the hydrogen, how many people felt okay about that? How many people felt maybe okay? And how many people felt bad about that? Please, can I see, please? Can I see okay, sort of okay, and not okay for that first calculation, which was working out the amount of hydrogen? Some of Church Army not happy. Wamawini, Dandora okay, Mathari okay and not okay. Okay, we will do Glory not so good. Okay, we will do some more calculations like that. Yeah, I saw you, Glory. I see you. I see you going like this. It's okay. Wamawini going, yeah, we can do this. The second one, on the one which we have just done on 7, how many people are okay about that one? How many people not okay about that one? Wamawini okay. Church Army not really okay. Mathari mixed okay. Dandora girls not okay. All right. We will do more examples of both of them so that you feel okay. What I want you to understand is that the mole concept doesn't have to be difficult. We always have to just work out the moles using one of the 3 triangles, and then it's almost always about a ratio. So we're going to end with one more question. Okay, so here it comes. one more question, and I'm going to show you how to do it, and then we will see how it goes. Okay, so come on. Okay, here it is. So this is rather like that one which we have just done. It tells me that a hydrocarbon has an RMM of 84 and it burns to produce 2.88 cubic decimeters of CO2 and 2.16 grams of water. Now, what you have to do with this is, even if you don't know how to work out the empirical formula, you work out the moles. In any one of these calculations, if it gives you quantities like this, volume, concentration, volume, mass, just work out the moles. So let's start by working out the moles of carbon dioxide and water. And I will construct it on the screen behind me, and then I will be able to go through it with you in a moment if necessary. I should have said take the molar volume of gas of 24. Okay. So I'll go back to my other camera. So here's the question. Here it is. Okay. I'll just put that up a bit. So this chemical here, X, burns in oxygen to produce CO2 and water. And it says 2.88 cubic decimeters of the gas and 2.16 grams of water. So what we need to do is to work out the number of moles of each one of them. So here, moles equals, this is the volume over 24 cubic decimeters, because it's in cubic decimeters. And this one is the grams over the RMM. When you've worked out the moles here, you work out the ratio by dividing each of them by the smallest one. Okay, and that will give you the empirical formula. So it might be 1 to 1, 1 to 2, 2 to 1, and so on. Okay, so let's have a look and see how we get on with that. One more, a little bit closer, please. Can you angle it towards me just a little bit, because it's the light is shining on it. I can't see it. Oh, hang on, up a bit. 144, I think you said. What have you got there? 2 point. So is that the moles of water or of carbon dioxide? Wamuini? sorry, move across just a little bit towards your right hand side. I can't see your calculator, I'm afraid. Oh, well done, Church Army. Well done, Church Army. That's really good. Carry on with the calculation, Wamarini. Get both of the moles and tell me what the ratio is. And just tell me what the ratio is, with fingers even, if you want. Mathari mixed. Wow, you guys are really good now. Wow, okay. Okay. That's really, really good. Come on, Dandora girls. Come on, Glory. Come on, Yestin. Come on, Sophia. Tell me the ratio, Wamuini. Oh, I thought you were going to shout out the answer there, Sophia. Really brilliant, Dandora. Well done, well done.
I want to give Wamuini a chance.
You want to give them a chance? Wamuini. Yes, Wamuini. Excellent. Really great. Yes. Everybody is getting it. That's really easy. It's really easy. Okay, so here's the next bit of the question. Here's the next bit. Okay. So the first bit is, what is its empirical formula? You can now tell me what its empirical formula is, and then you can tell me what its molecular formula is. To find its molecular formula, what you have to do is to work out what your empirical formula would weigh, what its RFM would be, and divide 84 by that. Okay? So many of you have got the right ratio. So what is the formula? What is the molecular formula, please? There's the calculation. And I think most of you found that the answer came out here as 0.12 and here as 0.12. Divide them both by, well, the same thing, and it comes out as to 1 to 1. So the empirical formula will be, well, now this is a bit more difficult because this is 1 carbon dioxide to 1 water, but each water has 2 hydrogens in it. And therefore the empirical formula, this is 1 carbon, that is 2 hydrogens. So its empirical formula will be CH2. This is why this is a difficult question. If you got the 1 to 1, that's fantastic, and you get 2 of the marks. But you need to know that the carbon, each carbon dioxide only contains 1 carbon, each water contains 2 hydrogens, and therefore it's 1 carbon, 2 hydrogens. That would have an RMM of 14. So what we need to do then is say, okay, what is 84 divided by 14? Because that's the number of CH2s I have. CH2. Wamarini seems to have an admiral in the back of the class. Somebody in a jacket which is very smart but doesn't get him any chemistry points. Church Army, what will the molecular formula be? Mathari mixed. Let's see who gives me the molecular formula first. We have a few minutes left. Yes, it's still a lovely jacket, but don't bother him. He's trying to work something out. Mathari Mixed has... Hey! Mathari Mixed, get gold. Mathari Mixed, get gold. Okay, let's see. Does anybody else have it? I will go through the whole question in just a moment. Okay, I will go through the whole question. Wamwini, do you have the answer? King Brown. King Brown gets silver. That is very good. Glory, have you got the molecular formula? Dandura, Church Army, let's have the molecular formula. We've only got a couple of minutes left. We want to try and get it. I'll show the whole calculation in just a minute, just to make sure we are okay. Church Army, have an answer. Up a little bit, please. Up just a little bit. C 6H12. Yes. Well done, Church Army. Church Army, get bronze. Get bronze. Everybody have to have a go. Glory, you can do this. Yes, you can. You can do this. Yes, you can. Dandora girls have the right answer. C6H12 is correct. That is correct. Well done. Okay, so I'll just go back to the other camera so we can finish by making sure we've all got this. I'm really impressed, guys. I am really impressed. Okay, so let's just go through this again. Okay, in the question, write down everything they tell you, okay? Everything they tell you is up here. And from here on, it's easy. So, first triangle for the water. I know moles is the grams over the RMM. That comes out as 0.12 moles. I know that for a gas, 24 cubic decimeters is 1 mole. So how much is 2.88? Well, it's 2.88 divided by 24, which is 0.12 moles. Now, the most difficult thing is that says 1 to 1, which is correct. But that's 1 CO2 to 1 H2O. And therefore, it's 1C to H2. That's why it's difficult. That's why this is quite a difficult calculation. That means that it is CH2, and CH2 weighs 14, and they told us right at the beginning that this weighs 84. So I say, okay, if CH2 is 14 and this weighs 84, I go, how many 14s? And that is 6. And therefore it's not CH2, but it's 6 of those, which will be C6H12. That is hexane. Whoops, no, it's not. It's hexene. My apologies. It's hexene, the alkene. All right, so back to the other camera. My snowball is melting. My snowball is now, it's up to 250 cubic centimeters. So I guess the total amount of water in this will be about 400 cubic centimeters. 400 cubic centimeters. 0.4 of a cubic decimeter produced, guys, produced 592 cubic decimeters as a gas. That means the particles in solids and liquids are 1,000 times closer together than they are in a gas. That is a very impressive amount. You have today done some really difficult calculations. Next time we will not be doing difficult calculations. I will make it much easier. And we will, yeah, Dandora going, yes, please. We will do one of each type of calculation just to make sure we have finished moles and we can do them and we can go out saying, I am a good chemist. Okay? Thank you very much for your patience. I will make a snowman for you and flatten it. And I will throw it at Yestin. So I will say goodbye and thank you very much indeed, Santisana, and goodbye. You are very good at chemistry. Thank you, Mathari. Thank you, Church Army. Thank you, Dandora. Glory. Silver Spring has disappeared, which is a shame, but thank you very much. Very much, Yestin.
Thank you. Thank you very much, Jama.
Thank you, Sophia. Nice t-shirt, Glory. Very nice.
It's the first time I saw